For thousands of years, wind energy has been used for many different avenues such as food production, transportation, employment, and electric generation. The U.S. Energy Information Administration in 2020 reports that wind energy had undergone extensive use by mankind as early as 5000 BC to propel boats along the Nile River. Wind energy today has been recognized as one of the cleanest sources of power generation that can be used to cater to mankind's demand for energy, and that can help facilitate some of the United Nations Sustainable Development Goals, including responsible consumption and production, climate action, affordable clean energy, and infrastructure, as well as sustainable cities and communities. This video will address the design, construction, and operation of the wind turbine, as well as a detailed analysis of its components. Mention will also be made about the advantageous effects such an innovation of sustainability has brought to the world. Naturally, any innovation to incur positive change may have its share of challenging implications. Such implications will also be highlighted during this report.
The wind turbine, operation and use, with science involved. When outside is very windy, or if there's a spontaneous increase in wind force, wind energy is caught by the propeller-like blades of the wind turbine. These blades act similarly to an airplane wing. When the wind blows, the less brunt side of each blade is manipulated by a pocket of low-pressure air, which makes the rotor turn. This process is called a lift. Another reactionary motion formed with the wind force against the front side of the blade is referred to as drag. The combination of these two forces causes the rotor to spin like a propeller. There are a series of gears that increase the rotation speed of the rotor, allowing the generator inside the turbine to produce AC electricity. For the average wind turbine, the general rotation speed is approximately 18 revolutions a minute and can potentially advance to a speed of 1,800 revolutions per minute. The nacelle, which serves as a streamlined enclosure, has vital components of the turbine. Such components include gears, rotor, brake, and a generator. The nacelle, which can potentially be large enough for a helicopter to land on, sits atop the turbine tower. The wind controller, another vital component of the turbine, keeps the rotor speed at a minimum of 55 miles per hour. This is to avoid damage by high winds. Wind speed is measured by an anemometer, which transfers the data to the controller. The brake stops the rotor mechanically, electrically, or hydraulically during emergencies. If there is no wind or decrease in wind force, the blades will move slowly and electricity will not be produced.
Design and construction of energy source. From a layman's perspective, the conventional wind turbine may not seem to have much of a visual aesthetic or a considerable set of components used to engineer it. However, one would be remiss to think that the functionality of the components comprising such a mechanism is based on kinetic simplicity. Depending on the type of wind turbine one examines, there is a great deal of activity under the hood. The precision and sequencing embedded in a wind turbine structure contribute significantly to its longevity, resilience, and energy output. The blade, which is considered the most iconic part of the conventional wind turbine, is usually made from carbon material or composite glass and is often rendered in an airfoil-shaped design. It is the main component used to harness wind energy through an automated lift or drag motion. It should be noted that for other modernized wind turbines, the shape of the blades may have alternative designs. Blade length and heft, of course, is very essential when constructing a wind turbine, as a very heavy trio of blades could lead to a wind turbine falling over its weight. Blades that are too light for wind turbines may exceed the designated rotations per minute and could possibly detach itself from the turbine tower. It is important to note that there are components connecting the blades to each other. Pitch controllers along with blade joints assist with the application of each blade to the rotor. One can only imagine how strenuous the exercise of applying each blade can be. With the exception of the tower and the blades, the nacelle usually chambers all the components of the wind turbine from the elements. The rotor of the wind turbine has similar functionality to that of a center hub on a regular electric fan. It connects the blades to the entire machine. The rotor also works in tandem with the generator. It can be attached from its rotor shaft directly to the generator, or it could be connected through a series of gears in a gearbox. These components work hand in hand in energy conversion. Wind energy from the rotor blades manipulates kinetic energy from the gears in the gearbox. Eventually, electric energy is generated as soon as it hits the turbine's generator. The yaw drive connects the turbine to its tower. It is sealed by constructors with frequent wind direction in mind, as it is always best to point out the wind turbine in the direction with the most wind output. Its functionality is somewhat adverse in effect to that of the static button usually found on consumer electric fans that is pressed to avoid it from periodically turning left and right. Such kinetic movements are facilitated by a yaw motor that takes part in the rotation process. The control system is basically the brain of the wind turbine. A control system can comprise of a number of computers used to consistently monitor and gather particular statistics of the conditions of the turbine. It regulates voltage or power distribution, speed variables, and frequencies, and is the hub used to ensure stability, similar to that of the benchmarking program on a computer. It goes even further by automatically adjusting the rotations per minute of the blades, the angle of the yaw wheel in order to adjust to a direction where there is a high degree of wind output. It also controls the angle of the yaw wheel so it can adjust in a direction where there is a high degree of wind output. The tower is essential for supporting the other components of the wind turbine. The Danish Vendor Industry Association in 2003 indicates that small towers can be made of steel, lattice, or concrete. Large towers, on the other hand, are predominantly made of steel. Towers are made of steel and are constructed to be from 110 to 150 meters high. Naturally, it is imperative that the tower of the wind turbine is sturdily footed to ensure good support from the rotor and nacelle components. The anemometer, though a seemingly insignificant component of the wind turbine, plays an important role in measuring wind speed. This kinetic information is converted to electric energy and sent directly to the controller as data. The wind vane is another component of the wind turbine used to measure wind direction. It is usually attached to the anemometer. One of the lesser mentioned components of the wind turbine is the brake, which is situated in the gearbox behind the rotor. With the use of the brake, kinetic energy potentially transforms into heat energy as a high or low braking torque is generated when slowing down or stopping the blades.
As the Earth changes, cleaner and better forms of energies are required for sustainability. During the integration of more effective forms of energy, advantages and disadvantages can be found. Notice that the non-renewable sources of fuel, including oil, natural gas, hydropower, and nuclear, are all significantly more expensive than wind and coal. Wind energy generated from windmills costs less than non-renewable energy sources currently being used in the world. As supported by energy efficiency and renewable energy, the electricity from wind farms is sold at a fixed price over a long period of time, and its fuel is free. Wind energy mitigates the price uncertainty that fuel costs add to traditional sources of energy. Countries can save a great deal of money over a period to help eradicate or reduce social issues if converted to wind energy. This low cost is related to the running and maintenance fees. Renewable energy, also called alternative energy, usable energy derived from replenishable sources such as sun, wind, rivers, hot springs, tides, and biomass. Noel Eckley, Ceylon 2020. The energy generated from windmills can be classified as clean or green since it is renewable and sustainable. According to Phil for Humanity 2013, windmills do not produce any carbon emission, thus they are considered clean energy sources that help fight against global warming. Wind energy is generated from God's creation, wind, and it is plentiful, free, and will never run out. The earth receives wind throughout the year, which makes it easier for most, if not all countries, to use windmills to generate wind energy. As explicitly stated by Malcolm Tatum 2020, since the source of this form of energy creation is so plentiful, it becomes a practical way to augment an existing power grid and thus minimize the use of fossil fuels in energy production. Some windmills today are different from the traditional windmills, and the reason for that is supported by the enhancement of modern technology. People can buy their own windmill to save money on their utility bill and support a green environment. The procedures of buying a personal windmill is relatively easy because they are small and easy to install without causing major destruction to neighbors. Smaller windmill machines are also relatively easy to maintain, which means the potential for an interruption in the capture of and storage of energy is less than with some other forms of alternative energy. Malcolm Tatum, 2020. The advantages of windmills include but are not limited to cost effectiveness, job opportunities, sustainability, renewable energy, clean energy source, low maintenance, and safety. While these advantages may seem endless, there are also challenges associated with the generation of energy through windmills. The fluctuation of wind is one of the main disadvantages solely because wind is needed to create the energy. Wind is a renewable resource and is unlimited, however, the constant movement of air at a certain speed is not always available to generate energy. A setback in the process is caused since various factors can affect the wind speed allocated and therefore will be deemed unreliable as a sole energy source. According to Clean Energy Ideas 2019, this can cause serious problems for the efficiency of a wind turbine as utility companies invest a significant amount of time and money in researching which locations are suitable for wind power. These locations include top of hills, offshore, open plains, and mountain gaps because of the fewer land difficulties, which can affect the force of wind. The cost is associated with being an advantage and disadvantage. The initial cost is high and can be too expensive for some economies. As supported by Phil for Humanity in 2013, windmill farms have a very high initial cost for purchasing and installing a large number of windmills. Even though the initial cost is high, it should be noted that the running cost is low compared to fossil fuels. Noise pollution is a negative factor, which can be derived from the use of wind turbines. As technology progresses, the eradication or reduction of noise have been significantly lower, but it is still heard and affects people and businesses in the area. You can sometimes hear them from hundreds of meters away depending on the wind direction. Combine multiple wind turbines with the right wind direction and the audible effects can be much greater. Clean Energy Ideas 2019. The use of wind turbines supports sustainability and also affects it due to the impact on wildlife and habitats. Traditional wind turbines kill species such as birds and bats. There are bigger threats to birds and bats besides wind turbines, but that does not justify the death costs. According to Clean Energy Ideas 2019, wind turbines still contribute to mortality rates among birds and bat populations. These creatures were trapped in the blaze and died brutally. Other organisms are now endangered because of the locations of wind turbines. Their habitats were destroyed to make space to build the turbines. As supported by energy efficiency and renewable energy, wind projects can alter the habitats on which they are built, which may alter the sustainability of the habitats for certain species. The disadvantages are noticeable and prevalent. However, they are subjective and will vary from country to country. The effectiveness of technology today helps to eradicate or reduce the disadvantages mentioned. The advantages precede the disadvantages, making wind energy a prominent source of energy needed for sustainability.
Undeniably, the wind turbine is a very impressive machine. Its sleek exterior design is quite deceptive, considering the functionality and energy conversion happening under the hood. One can only anticipate that as time goes by, its associated challenges will be mitigated and its technology will become more and more advanced, perhaps to the point where it requires little to no intervals of maintenance from man. Who knows? Perhaps the wind turbine could eventually become a full-fledged alternative energy consumer product one day, and electric utility costs attributed to corporate organizations will either be minimized or become a thing of the past.